Hello and welcome back. Today we're making something in Godot. This is a project I made a while ago in Unity, but I'm remaking it in Godot, remastering it, and putting it online so people could actually use it. So yeah, let's just get started. Let me show you guys where I'm at. So I basically made a first-person control, like character controller. That's not gonna help much because it's not a first-person thing that I'm making, but I still like it honestly. So yeah, we made this so far. It's pretty cool, but this is not where we're headed towards. So yeah, what I'm gonna do is I'm gonna create a camera, another camera. Let's see. Okay, because basically the camera is supposed to be locked off, right? So inside this world node, I'm gonna add another child node, and we're gonna go camera 3D. There we go. Now we have another camera here, and can we see the view? I guess not. So what I'm gonna do is I'm gonna set the transform to up here to like, I'll say like 1.5 maybe, and then we're gonna move it back. No, not that way. We're gonna move it back on the z-axis by to like 10 maybe. Let's see what that's looking like. All right, so now that's gonna be that's the only camera I want inside the actual thing. So let's delete this head node, and now when we play, it should be from that. Oh, there's something's wrong. Let's see what error we have here. So add function physics 58 line 58. Yeah, head position. There is no head. So that's a problem. But really, we don't really need a crouch anymore. So we can just remove this all, and then we can select all of this and put it back to where it was. We're gonna save that. We're gonna remove also this this thing right here, this input mouse thing, and we're gonna keep the thing, the mouse, whatever. We're gonna keep the mouse on screen. We're gonna remove this function. We're gonna remove this ready function, and I think that's all we need. So some of these functions are not used anymore. So like the mouse sensitivity, we're not gonna use that. We have direction. We don't. It's still here, but we're not really gonna use it. Let's just now. Let's remove that. Let's run our game again and see what we get. Oh yeah, we can't see the character because it doesn't have any mesh attached to it. So what we're gonna do, we're gonna remove this first for this capsule. We don't need it, and we don't even need this raycast thing. This was just all for the first-person controller that I made earlier. So now we have a standing collider shape. Visibility, we have visibility on, visibility parent. We should probably create one. So let's do that. So at player, we're gonna create add child node, and we're gonna have let me write like capsule or something, or is there there's collision shape. Is there a mesh thing? Mesh instance 3D. We can do that. We're gonna create, and we have it here. So the geometry, we're gonna have mesh empty. We're just gonna put a new capsule mesh right here, and there it is. And we're gonna move it up, so the transform is gonna be, I think it's 1.6. I think I have it 1.6. I think I have him. No, that's way too high. Let's just see where he's at. So standing collider shape, we have the transform at 1. Okay, that makes more sense. So let's put it at 1 there. So now we have a capsule inside our mesh. That's perfect. What we're gonna do is we have now we have a mesh instance. So and the shape is already, oh no, this is something different. So visibility is on, and we can do that. That's our, I don't know if that's how this works or not, but I'm just gonna pretend that is how it works. So now if we play the game, we see our character and we can move him around, which is pretty amazing. That's what we want at this point. So yeah, that's perfect. Now, since we want this to take place on a planet, so I'm gonna make the stage a little bit. Why is the shape like that? I don't understand. Oh, okay, because it includes this thing right here. We're gonna remove this box right here. I don't need that anymore. That was just testing the crouch. So we're gonna make the stage a little bit bigger. Right now it's 20 by 20. We're gonna go maybe 50 by 50, honestly. So let's copy and paste that as well to this Z value as well. And what? Oh, whoops! Did not mean to do that. Now, if we go to our, there's no way to really check the camera view, is there? Yeah. No way to, or wait, there has to be a way, I think. Let's see. Camera. Okay, maybe not. Alright, let's play it, I guess, and see what we see from here. There we go. Now we have our view here, and we can move our player around. He moves and stuff, which is good. Yeah. So now we want... I'm going to see if I can mess with the camera settings to make this look like a planet. So, let's go to camera 3D. We're going to go... Here we have it right here, field of view. But there's no way to look at the camera view. Oh, okay, preview. Okay, there we go. This is what we wanted. So I can disable that, enable it. Okay, so let's look at the camera view and let's try to make it more... No, not that. That's not it. That's not it. Let's see. Projection. No. What? No. What's going on? Perspective. Is there no way to... I'm pretty sure there's a way... New camera attributes, practical, physical. What should I use? Let's do that. Whatever that means. So now if we go here... Okay, now we have some actual... I don't know what's the difference between physical and... Depth of field, auto exposure, resource. So what is this? That's practical. Let's do physical. Let's see. Now we have frustum. Alright, so let's see. Focal length 35. We're gonna wanna... we're gonna wanna have it pretty low. Like 15, honestly. We can't have it too low though. Do like 15. That's good. Focal distance. I don't even know what this does, so we're just gonna not mess with it. Exposure is fine. Auto exposure, resource. Local to scene. I don't know what that means. That's not exactly what we want either. So, environment. No. We have an environment here. Quick load. Okay, no we don't. Maybe, I don't know. Let me try to actually do the practical one. Depth of field, blur. Okay, so exposure. No. Actually, the other one was better. I keep going back and forth. I gotta stick to one. But this is fine. Wait, no, that's not what what am I doing? Finally, okay. Frustum. We're gonna do 12 millimeters. Right? That's good enough, I think. And yeah, let's see what happens when I move the camera closer. Okay. No. Okay, we'll just keep it at 12 here. That's good. Now what we're gonna do is, well, first we need a bounding box for the player, but we're gonna handle that later. Exposure is fine. I don't care. Auto exposure. All right, so that stuff is not important. We're gonna go process. Okay, there's nothing we could really change, like no effects, post-processing thing that we can add. Oh my god. 1 second. Okay, I don't care. Alright, so let's see if we can have any post-processing. There has to be a way, right? Maybe under environment, under world environment, there's like post-processing. There we go. See, that's much better. So, the sky, low-key, I gotta change that, because this is supposed to be like a different planet. So what we have inside our assets is this storm HDRI. What we're gonna do is we're gonna add new, or no, can we import it or something? We're gonna have to add it through File Explorer. What is going on? We're gonna import it through File Explorer. And okay, let's go here. No, it's wait, is it here? 3D models, yep. Textures down here, and we're going to have HDRI. I'm pretty sure, yep, right here. Now we have a bunch of these. We're gonna use like a space one or something if we have one. That's the thing, they take forever to load. I might just use like an image for now, like this. Even though it's technically not an HDR image, but it's fine. I just want it for the like colors. Alright, so yeah, we're just gonna use that for now. We're gonna put it into our assets folder. It doesn't go inside our assets folder, amazing. I'm gonna drag it into our assets folder. There we go, we have it there. And now for the sky, what we're gonna do is we're gonna go change this to quick load. And we're gonna go download that JPEG. That is horrible. What is that? There's no way that's real. Is that real? What is that? That's horrible. Okay, let's go back to textures, HDRI. Is it that bad? Oh, 292 by... We see the dimensions here. 300 by 168. That's not good. Alright, let's see. It has to be something else. This is 6K. So that's good. That's going to take a while to import, though. And it's definitely going to take a while to put on the actual scene. Like the game. Let's wait for it. Please don't crash. It didn't crash. Amazing. We're going to save our scene. We're going to drag this into assets. Please don't crash again. Please don't. Please don't. Please don't. Is it even... Did I click drag? Okay. What? No, that's not what I meant to do at all. That is not what I meant to do at all. How did that even happen? No, drag this into assets. Thank you. What's going on? What's going on? I don't understand. Why is it still like that? So confused. I'm so confused right now. What's going on? Huh? Godot. Wait, alright, let me undo this. Wait, no, I'm doing the wrong stuff. Why is it doing that? Did I drag it onto the... What did I do? What did I do that made this happen? Alright, whatever. Let's replace the sky with quick load, and we're going to have our whatever this is. There we go. It looks a little better. I don't know why the floor changed to this material. Don't know what's going on. We're just gonna What is going on with this thing? Why is it like that? I don't understand. Alright, we're gonna just delete it and make a new one. I don't even know what's going on. Alright, add child node. We're gonna have a box CSG thing. Box, and then we're gonna have, okay, what was it? 50 by 50. So 50 by 50. Then we're gonna have it, we're gonna lower it by how much? We're gonna hold control. Just 0.5 actually. 0.5. Oh wait, no, that's the scale. Transform, negative 0.5. There we go. Now we can add a material onto it. Let's see if we have, do we have any materials already made? No, new standard material, 3D. We're going to click on it, right? And then we're going to go to albedo. Texture, we're going to quick load this wood texture. Where is it? I think it's, yeah, textures.com wood planks. There we go. And for the UVs, because it's a little, this is just temporary, of course, but yeah. We can do triplanar. That's not looking good. So we're just going to change this to like 12. 12. Alright, that looks better. Alright, so now if we look through our... Okay, we don't even have a camera. Where is it? There we go. If we look through our camera perspective, that's what we're looking at. Not bad, honestly. World environment, we're going to have... We have the sky. Ambient light, source, color, background. Amazing. Energy. What does that do? Nothing. Alright. Let's see. Reflected tone map. Reflected light. Filmmaker. Okay, that's correct. I'm just looking through and seeing if there's any post-processing stuff. Fog enabled. We could do... Yeah, we can... Nope, that's not enabled. Let's do volumetric fog. That looks better. Ooh, that's a little bit heavy, though. Let's do fog for now. And then, density, we're going to do more dense. But then, sky effect is going to be less. So we can actually see the sky. Less dense now. And then the color of it is going to just be like... The color of the fog will just, like... It depends. We'll just leave it like that for now. And does that look good? I can't tell. Really? Honestly, I can't tell. Let's play with the settings a little bit more so we can make it cooler. So let's how do I select the... Oh yeah, world environment. Now we're at fog. Let's see light energy. Oh no. Let's leave it at 1. Sun scatter. What does that mean? Don't know. Okay. Don't know what that does. Aerial perspective. Sky effect is at 1. Aerial perspective. We're gonna just maybe turn this up a little bit. Blends fog's color with the background of the sky. Okay. That looks nice. I like that. Height. I don't really... That's not gonna... It's fine. Height density. Oh, okay. That's pretty cool, but we don't really need to do that. So that's fog. Volumetric fog might have looked better, but yeah, it probably does look a lot better. All right, let's enable it, disable it for now, and then we're gonna try volumetric fog, see what it look like. Dang, we should have the same settings, honestly. Okay, we can't really do the same settings. I don't know what to do here. I'll just leave it like this for now. Like this, so we can still see the sky and stuff. Wait, no, what? Why'd I go to 0? Somebody's calling me. Oh, 1 second. My dad is calling me. Hello? Yeah. Ferran, okay, I got it. Okay, bye. Wait, Shell Ferran, Zed. Wait, what? Shell Ferran, Zed. Apologies. Back. I don't understand this. How is the density at 0? I don't even need these. How is the density at 0 and it's still foggy? I don't understand. What's going on here? Let me remove this. Put the density very low. There. How's it going up? Why is it going up? Let's see. Oh my. I'll just do a manual number there. Manual. Alright, that's good enough. I don't care. I'm just going to leave it for now. Volumetric fog. We're just going to leave that. Camera attributes. It's the same thing as Wait, why? What does this have to do with anything? Okay, no. Just clear. Alright. Alright, so we got the fog. So now adjustments. Enabled, of course. Yeah, we'll enable that. And resource. Okay. Is there any like post-processing node I can add? Add child node. Let's see. Viewport post processing. No, there's nothing. Let's see. Okay. Add metadata. No. Let's see. Process. Alright, so that's for our environment. I thought I just deleted it. Oh my god. Alright. So we have like our basic environment stuff done. Let's save it. I still want like the world to kind of curve a little bit. If there's a way to do that. There's some warping with the camera. Let me Google if there's a way to do that. Camera warp Godot. Hopefully there is, but who knows. Hmm. I want to make the camera work on warp on purpose. Oh man. Effect. Godot. Hmm. Let's see. Okay, I don't even know what to do here. I'm just gonna leave it, I guess. Nothing much I could do. Is there any like camera effects I can add or anything? No. No. Editor description. No. Alright, we're just gonna leave it like that for now. Okay. So we have our player here, and if let's run the game now. Let's see what it's looking like. Why is he just going through the? Why is this mesh instance? This should be shape. Why is the collision disabled? Oh no, why it's not disabled? I'm so dumb. Yeah. Oh, I'm supposed to have this under here, I think. I don't know, actually. No. Never mind. Wait, so why is it going through? Why is it falling? Maybe, is there physics enabled or something on here? Skeleton skin. Mesh, okay. Geometry. Ability, sorting, transform. Why is he falling? I don't understand. I don't get this. Mesh instance. Okay, so this should be. I don't understand at all. Standing collider shape, yeah. Can this be under here? Oh, can this be under here? Does that work or not? Nope. Wait, let me see. You want to play mode? What? I can't. See what errors we have. Node not found. Head. Let's go to script. We're gonna see. Alright. Right here. Head is not found. So let's remove that. Oh yeah, we gotta remove all of these, I think. Yeah. Alright, so let's save it now. And let's run it. See what happens. Maybe he'll still fall through. Who knows? Yep, he still falls through. I don't know why. Don't understand why. Don't know what's going on. Let's remove this mesh instance 3D. Let's just have this collider shape. Well, I don't even know if he's gonna fall through or not because I can't see. Amazing. So we just add a child node or 3D. Alright, we're like mesh, I guess. Mesh. And I'm guessing we're gonna just do that again. I don't understand. I don't know. Yeah, mesh instance. Okay. Let's see. Mesh. We'll just do like a box or something. Cylinder. There we go. Let's see how this works. It's gonna fall through, isn't it? Capsule mesh. Yep. So fine settings. I don't care. That's good enough. Why is he falling? Why is my mesh falling? I don't understand. Skeleton. Skin. players. Visibility, geometry. Why is he falling? I don't understand. What's going on? Let me Google. Why is my mesh falling? Godot. Oh my god, this doesn't help at all. This is a static body 3D, yes, correct. Use collision. Why is use collision not on? No way that's the problem. No way that's the problem. Why did it get turned off? I didn't turn it off, did I? Oh, I added a new one. Yes, I did turn it off. I'm so dumb. Oh, that's bad. That's bad look on me. Alright, sorry about that. Alright, now it works. That's good. We have a player that moves around. Alright, so now I want to like change the gravity. So under world, we're gonna add a script here. So we're gonna do plus, and then we're gonna put this inside scripts folder. Scripts world. I guess that's fine, right? Create. Alright. Now we have the script, and we're just gonna have a variable. So export variable gravity. Is it gonna be equal to, I guess, 10 or something? I don't know. Let's first let's go to the player script and let's see what the actual gravity for our settings are. Or I think we can see that here. Project settings. Where is it? Physics. General. Physics 3D. Gravity is 9.8 default, so that's like Earth gravity, I guess. Earth gravity. Wait, if that's Earth gravity, then we have to have our astronaut be this actual mass of an astronaut. So, how heavy is an astronaut suit? I'll just say plus. Okay, how heavy is an astronaut suit? Weighs about 180 pounds. Okay, wait. Player, do we have like anything? Floor. Okay, moving platform collision input transform. Do we have anything that decides the weight? How do we do that then? How do we do that? Collider. Change weight of player. Godot. Is there nothing about weight? Physics body 3D, yeah, okay. I don't know. I don't get how to change the weight. Let's see. Player, character body, motion, grounded, floating, slide on ceiling. What does that even mean? Floor, moving platform, collision. What? Axis lock. That could have come in handy as well. Input, transform. Of course, it's not going to be in transform. There's nothing to add weight to our player. We could simulate the weight. If I'm being honest, we could do that. Let's try to do that. So, because here's how our gravity works basically. Our velocity.y is minus equals gravity times delta. So, if we can't affect the weight of the character, it will affect the gravity of the character. So that means variable gravity. I'm going to have to add a variable is equal to weight. Or I will write player weight, right? Okay, amazing. And then we're gonna write what is it? Like about the suit is about 180 pounds plus like about 175 for the male. All right, so we could just have that, and then player weight. So gravity is going to be multiplied. Let's just multiply it by the player weight and see what happens. Alright, let's see. Can we do that? If we run it and let's try to jump, I doubt it's gonna jump for what the thing. Okay, that's not good. Player weight. That's bad. That's bad. That's not supposed to happen. All right, let's take the player and then move him up. Why is it snapping? How do I? Okay, hold shift to turn it off. I guess we're gonna move him up like right here. See what happens. Play it. Okay. Yeah, you can't really jump at all. So we're gonna have to increase the jump force, jump velocity. Well, technically we'll just call it jump force for now, because that's a little bit more accurate, even though, because this is not only acceleration now, it's also weight. So jump velocity is gonna be jump force, and we're gonna have to change it elsewhere. So yep. So now we're gonna have jump force is gonna be equal to, we'll do 45. Let's see what happens when we do that. So we'll run the game. Ooh, that gravity is harsh. That gravity is harsh. Let's do like, instead of 45, we'll do like 450. Let's see what that happens when we do that. I mean, that is technically like Earth gravity, but it's a bit much, honestly. So what we're gonna do is we're gonna normalize the values instead. So we'll just keep it at 4.5 for now, 4.5, and we're gonna normalize these player weight values. So it's gonna be weight. Okay, oh, that's not even how you comment. Weight of the player in pounds divided by any normalizing value. So we're gonna divide it for now by like 10. Let's see. Let's see where we get at. Divided by 100. I like this a little better. This is like Earth, how high you can jump on Earth, right? This is a lot better. I like this a lot better. So now, for gravity, instead of getting it from project settings, dot get setting. Can you do dot set setting? Project. Can I do that? Set. Okay, well, can I do? I don't even know if I can do that. Let me see. Set underscore setting. Yeah, you can set the setting. Okay. It's setting, and then we're gonna go to world. Our world gravity is gonna be. For now, we'll do 9.8. 9.8, and then we're gonna do instead. We're gonna do on the, as soon as the function starts, we're gonna go project settings dot set underscore setting, the name, and then the value. So we're gonna go to, where were we? Player. This setting, we're gonna change it to the gravity. So right here, we're gonna go there, and then value is gonna be gravity. So now we basically set the gravity whenever we want, whenever the game starts, to whatever we want. So now if I run this, as you can see, this is like the Earth gravity. I'd say that's pretty good. And if I want to change that, I can go to world, and I can make the gravity a lot less. So I could do 3, for example, 3 meters per second squared, whatever gravity, whatever the stuff for gravity is. So if I do 3, he should jump a lot higher, but he doesn't. So the reason that is because So instead of going to project.get settings, wait, what? That makes no sense at all. I swear I changed the gravity, didn't I? Cause when I ran it, this script should have ran, and it should have changed the gravity, right? Or am I wrong? Am I right or wrong? So if I run this, that's crazy. I don't get it. I don't understand why that's not working. Let's see. Player times player weight. Yeah. Maybe because the 3 is still high. Maybe. But it shouldn't be. I don't think that should be the reason. Because let's say if I put it at like 0.05. Let's see if I put the gravity very low. Let's see what happens. Still the same thing. Okay, so there's something wrong here. Something's wrong here. I don't know why this function seems like it's not getting called. Project settings dot set setting. Let's see. Let's say console. Wait, how do I print? Print. We're gonna go project settings. Get setting. And copy and paste this to here. Let's see what happens when we run the game now. It should print out the gravity here. 0.05. So why is that still like that? Maybe let me go back to player. I'll just remove the player weight thing. I'll just remove it. And this should now work. Now we have it working. Right? Now if I put 9.8 gravity. Wait, don't tell me if the higher the value, the same thing, same exact thing. I don't understand. I should do that in here. So function ready. Is there any parameter for it? Okay, no. I'm gonna do this same exact function. Same exact same exact thing. We're gonna run. So let's we're gonna remove it from, or just comment it out from here, and we're gonna run the game again. Let's see what kind of gravity we're gonna get. 9.8. So now we're at 9.8 gravity. If we change it to 3, set gravity. Now if we, okay, well let's run it again. Now if we run it again, gravity's still 9.8. That's not supposed to happen, right? It's supposed to be player is supposed, the gravity is supposed to be different. So why is it like that? I don't know. I'm guessing the only real way we can do it. I'm guessing we're gonna have to reference the gravity variable inside the world. Even though I don't want to do that, but I'm guessing that's the only way to do it. So, what in the world is that? Wait, no. How do I drag it as a? Okay, I guess I can't do that. Can I do that or no? Okay, maybe I can. All right, whatever. I'm gonna just do it right here. Equal to. Wait, is that even allowed? Can I even do that? Row dot. So project settings is going to be, gravity is going to be equal to. Okay, all right, okay. It's frozen. All right, I gotta figure out what gets executed first, this or this, you know. But for now, I'm gonna say, like, once the player gets initialized, we're gonna put gravity as, I'm gonna do it like this: add export variable gravity is equal to, Right now it's going to be equal to world. Oh, wait, is that? Can I reference it? Dot gravity. I think that's going to be fair. Can I use export annotation because the initialized value can't be inferred? What does that mean, can't be inferred? Yeah, you can. It's literally inferred right here. Alright, let's say we don't have it inferred. Alright. Let's see if we can run this now. And it'll print out the actual value of gravity. No, it doesn't. Get index gravity based on... What does that mean? Delta is never used in the function process. Yeah, okay, I don't care. So what? I'm just gonna... Hold on. No, that's not what I meant to do. Pass. Integer division decimal part will be discarded. Event is never used in underscore input. Okay, so what? Where? Okay, I guess, yeah. I guess it's not. It doesn't have to be used though. That's not an error, is it? What is going on? Index gravity on base. Gravity is null. How is it null though? How do I reference? Okay. Reference a variable from another script Godot. Let's see. Let's see what they give us. Alright. Very likely that you don't want to do what you're trying to do. Events. Use signals to communicate with objects. How do I use signals? Okay. Variable world on ready. Variable world. Player.property. That should be working. World.gravity. I'm gonna just say, I'm just gonna do this. I'll just say no for now. Or we'll just, I think that's gonna make things worse. I think so. Oh no, it's not. So now the gravity is actually 3. Amazing. So now we can change the gravity with the world. That could cause a lot of errors, but who cares? Wait, oh yeah, okay. So now if we go to world, wait, did I click it? Okay, yeah. World gravity, so 9.8. That's good. Now if we go to script, what did I have before? I had it multiplied against the player weight, right? Damn, my back is itching. But yeah, I had it multiplied against the player weight, the normalized player weight at least. So let's see what happens. That's not how a normal human jumps, so I'm going to do the same thing as before. So times player weight. Now if we run it, it should be a little bit more realistic. Yeah, there we go. Now this is more like Earth's gravity right here. And the jump force is fine. Amazing, amazing. Oh my god. But yeah. Now we have everything accurately set, right? If we go to, like, yeah. Now we have that part of our world defined. Oh, I forgot, there's so much math within this project, it's ridiculous, but, like the world, at least we've got that working. It's looking good so far. So, not only do we have to figure out gravity, but we also have to figure out, like, orbits and stuff, how long a day is, things like that. A day is basically 1 revolution around the sun for a planet, but we're not going to move this plane 1 revolution around the sun. We're going to move the sun 1 revolution around it. That's the real way it actually works. They didn't tell you that in school, but okay, so let's get to moving. So we're gonna have to make like a sun right now. So I'm gonna, oh, well technically we do have a directional sunlight here, but I think we're just gonna rotate this with some random object that we create. So we're going to go, I guess, into our stage. I'm gonna add a child node and then add a, what is it called? Sphere. CSG sphere. Move it back here. We're gonna have to make it a lot bigger. What does it look like from the camera view? Let's see. We're gonna make that sphere a little bit bigger. Let's see. Oh, whoa. Chill out. Why is it so... Okay, we're gonna have to make way more segments. Rings. Not rings, actually. That's what we need. Alright, there we go. You don't need that many segments. That looks good. Alright, now we have like a decent sphere. It should be smaller, honestly, because the Sun 3D, we'll call it Sun 3D. And we're going to get out of this preview view thing. And we need to define an orbit for it. So, if only there was a way. Make an object orbit another Godot. Let's see. How do we make an object orbit? Is there like a, there has to be a way to do that within Godot already. Let's see. Okay, I'm guessing we are gonna reset the transform values here, 0. And no, let's not do that. So we're gonna need an orbit script. Oh my god. We're gonna need an orbit script. So, or not, I think we'll just do that in the world script. So, oh my god, this is killing me. Alright, let's see. How are we gonna define this orbit script? There's gonna be some math stuff involved in this. Okay. Let's say we're gonna start off. We're gonna probably start off the sun right here. It's not gonna have any collisions. Oh, it does have. These collisions is off. Okay, good. So we're gonna start off the sun at this distance, and we're gonna write I'm gonna put this as a variable here. Sun 3D, and then we're gonna write export. No, we're gonna just write variable distance from origin. It's gonna be equal to, and then let's say we want like about maybe 64 meters. Right, 64 meters I think is good. So we'll put 0. We don't need these values don't need to be accurate because that's gonna be stupid if it is. 64 meters. Now we have that. On ready, we're going to okay. So we're going to modify the position based on the time of day. This is not easy stuff, not gonna lie. What other functions are there in Godot? I'm very new to this. Something that has delta, process delta, anything else that has delta. Alright, So it's going to be either physics process or just the process. That's every frame though. Physics process is every physics thing. I don't know. But I think we're going to do physics process for that one. So, to orbit, so I need, let me get pen and paper. So depending on theta is going to be x and y position. It's going to determine our x and y position. Let me show you guys what I'm writing exactly. So let me make sure you can see. So what I have basically is depending. Oh, you're not gonna see because the focus. I'm so stupid. Alright, I'm gonna have to manually adjust it. Give me 1 second. There we go. So depending on this, this variable right here, theta, that's gonna tell our coordinates for the sun. Oh my god, I can't even. That's gonna tell our coordinates for the sun. I hope you can see it. I'm not really doing the best job of showing it, but that's what essentially we're going for. Let me fix the focus now. I think that's good. Alright, that's essentially what we're going for. So yeah, it's just sine and cosine pretty much. So it should be easy to figure that out. So, wait, okay. So when theta is 0, so we're gonna have a variable as well. Variable theta starts at 0. And then function underscore physics process delta. Let's see, theta, and then we're also gonna write speed of orbit. And this right here is gonna just have a regular value attached to it right now. And we're gonna fix that later to make it actually accurate. So, oh, you're not looking at me. You're not looking at what I'm coding. But basically what I wrote was this function right here, the physics process, and then I have these two variables that are very important. So, theta, print theta, plus, I'm going to write delta, times speed of orbit, right? So we're going to do this, we're going to run this and see what happens. So let's see. It's printing out the same thing. Theta 0 plus delta times speed of orbit. Let me just write delta then, I guess. I don't know. Delta should be a different number every time, shouldn't it? Or should that be under the physics? Should that be under the regular process thing? Let's see. See what happens. Run it. That's just frame rate. That's just depending on our frame rate. So we're gonna go back to how we had it here. Delta plus. Wait. Okay. No. Theta is gonna be equal to delta plus speed of orbit. Oh no, just theta plus equals is gonna be to delta times speed of orbit. So now we can just print theta by itself, and we should get a like result that keeps going over and over and over, like up and up and up. 9 to 12, yeah. And we have to clamp it like I'm gonna guess 360. So I forgot how to clamp. Let's see, I did it over here. So let me just write clamp. Oh, I didn't clamp. I swear I wrote a clamp thing here. Oh no, I had it, but then I removed it. So what we're gonna do, I think, where did I have it at? I wrote it somewhere. Let me see where exactly I wrote it at. Alright, I'm gonna say like yeah, on every frame we're just gonna clamp the values of the sun thing. So, or should we do it? We'll just do it here. So clamp theta equal to clamp theta in between 0 and 360. There we go. Now it won't pass 360. If we run our game, we have the values going up, 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 and it's not gonna look at the thing is casting a shadow. We're gonna really have to wait for it to get up to 360, but okay, any day now. All right, no, I'm not gonna lie. Let's go. All right, now it should reach our target a lot faster. There we go. So now once it hits 360, clamps. So it can't go over 360. So then we're gonna have another if statement here. If theta is equal to or is greater than or equal to whatever 360, then I don't need to have this stuff because it's like Python. I love it. Then theta is now gonna be equal to 0. Then we print theta. So now it's gonna loop. So now if we run it, you're gonna see it's gonna go in a loop. Amazing, 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 amazing. So now we just have to make it actually like change the actual coordinates of the thing. So what we're gonna do is first we're gonna change the starting position. Now the starting position is just gonna change the z-axis to like -62. I think we decided on, or something like that. So on ready, we're gonna have sun underscore 3D dot position dot z is gonna be minus equals, what was it, minus? Wait, from where's the camera pointed at? Oh, it's that way. So it is minus, yeah. Minus equals distance from origin. So that's where the sun is going to start. So now if we run this, of course, the sun is going to just be back there. There we go. We see it in the background. Amazing. So now we have to move it based on the physics process thing. So to do that, we're going to change the z. Yeah, we're not going to do that. We're not going to do that. We're just going to comment this out for now. We're going to have to change the z and the z and the y position on this thing. On this thing. The z and the y position. So the z position is essentially the x position, which is going to be cosine. And then the y position is oh man, this is confusing. I'm dealing with different axes and stuff like that. It's very confusing. But what we're gonna do is we're going to have theta. So we're gonna change the sun underscore 3D dot position dot z is gonna be equal to sine angled radians. So we're gonna have degrees underscore 2 radians. Even though it should be radians to degrees, honestly. Let's do that. Radians underscore 2 degrees. No, it's degrees to radians. I'm tripping. Because that's what these functions take in. Degrees to radians. So we're gonna have theta. This is supposed to be cosine. Theta. And let's just see what happens when we do that. No, let's not do that. Let's just print this value right here. So we're gonna go here, and we're gonna go here. We're gonna take this, we're gonna change that. And now let's see what happens. So it's just looping basically. So now what we have to do is we have to multiply that by the distance. So what we're gonna do is cosine, and we're gonna multiply it by distance from origin. Now you should see the sun's position changing on the z-axis, at least, right? It's very fast, so let me lower it down a little bit. Let's do like 75. Okay, that's good though. We have a good result, and I'm gonna have to add some like lerping, but we'll do that later. So now we have that working. Now we're gonna have to also adjust the Y position. That's just gonna basically be the same exact thing. Well, not Y position, I think it's X position. No, it is Y position. That's gonna be basically the same exact thing, but instead of cosine, it's gonna be sine. So let's run it now. Let's see what happens. Wow, we did it. We did it. It's orbiting. It's actually orbiting. That's amazing, honestly. That's amazing. Yes! Now, if we crank up the speed, it'll look pretty cool, I think. 225. Let's see. Yep, now it's like just... That's amazing. We could also use this script with the asteroids and stuff as well. Ooh, yes. Yes! Okay, amazing. Yeah. We should just put this in a whole function in itself. Or put this script inside. Oh, this is already inside the sun. Oh no, it's not inside the sun. So we should have this script instead of editing it from here. We're gonna put it in the sun thing. So yeah, we can do that, and it's gonna look pretty cool. So we did very good here. Right now we're just gonna add a script. We're gonna call it. I'm gonna go here scripts. Orbit script. We can create it. There we go. Now we're basically just gonna import. Technically, I could have done some actual physics-based orbiting. That would have been way too complicated, though. I'm good on that. So let's just. Damn, it's hurting my ears. So let's just copy and paste some of these variables to here. So let's do that. Variable distance. Then theta and speed of orbit. We're gonna do that. Oh, not inside there. We're gonna do that here. And we have the ready function doesn't have anything. It's mainly just this stuff. So we're gonna go here. I'm gonna put it inside a function. Physics process dot delta. Alright, I'm back, and it is very late at night, but we're here. Hold on, let me put my phone to charge really quick. 1 second. It's 2:19 a.m. and we're still here. So yeah, basically last time we were trying to find out a way for us to, instead of setting the speed of the orbit, we want to set a time for the revolution, right? And a way to do that I found was, so basically let's just use some math here. So let me just, for example, so we have the speed of the, for example, we're gonna have speed. In this case, it was equal to. Oh, I'm not showing my screen. Sorry about that. All right, yeah, but this is where we were at. Instead of using the speed variable, I want to use a time variable. So this is how we're gonna do that. So our speed, or let's comment this out. It's just math, simple math. So our speed is equal to, or our speed in this case, 100, is equal to a time for one revolution, 3.6. Because this 100 was here, and it's equal to like 3.59999, which is 3.6. So speed is equal to 3.6. So we have to multiply speed by something to equal 3.6. Now, how do we find that something? Well, it's easy. We divide 3.6 by speed. So that means that x is equal to 3.6 divided by the speed. You know what I mean? See what I mean? And yeah. Wait. No, sorry. The speed is not supposed to be. It's not supposed to be speed. Well, it is speed, but we're just going to use the number 100, for example. So 100 times x is equal to 3.6. Then x is 3.6 divided by 100. So this gives us our constant of x, which is equal to, yeah, we already have it. So this constant is basically, that's essentially the time for one revolution, okay? It's not exactly the time for one revolution, but to get one revolution at that's to get one revolution. Wait, what's wrong with me? Yeah, that basically has a wait. Huh? What? What? Meters per second. This is just seconds, so this has to be meters. Because, but it doesn't cancel out. So that has to be 1 over meters. Wait, what? I'm very confused right now. Thought I'd figure this out. Did I write it down somewhere? I swear I wrote it down, but I don't remember where exactly I wrote it down. Okay. Let's see. Where did I write it? I don't know. This is very confusing. Very confusing, I'm gonna be honest. I'm trying to figure this out. How to make it timed, you know? So that's speed 100. It's that. Time for one orbit, I guess we're just gonna put it as 3.6 divided by 100. We're gonna see if this does anything. So time for one orbit. Oh my god, why am I so stupid? Time for one orbit is gonna be equal to, so this is gonna be time for one orbit. Time for one orbit is equal to the speed time for one orbit is going to be equal to speed, but no, we want to determine the speed off of that. So this is going to be the speed times 100. Okay, so we're going to delete this. We're going to have this. And then we're going to have this right here. So the time for one orbit, we're going to say 10 seconds, right? I don't know if that's seconds or milliseconds yet, but we'll see. So that means the speed, which is x here, is going to be equal to time for, okay, just copy and paste it, time for one orbit divided by 3.6 divided by 100. So that's the speed of the orbit. So we're going to see if that is true. So let's run it, and we'll see how much it takes for time. Takes to make one revolution. Let's see. 1.3. So that's, I'm gonna guess this is milliseconds. Or no, that's not millisecond. 10. Oh shoot. That should be... Maybe I'm going to take one number off. Let's see if it's going to take 10 seconds this time or not. It looks like it's going to take 10 seconds. Let's see. Let's see what happens. Okay. This math is so bad. Oh, that's horrible. 12 seconds? That's way off. Maybe I should just do speed of orbit. Maybe it's 1.6 because I'm pretty sure the physics, most of the time physics, I don't know, physics takes place within 1 second. Oh, that's not going to be it. That's going to be way worse. This is bad. This is bad. This is bad. What if I just do like 2? What would that do? What's 2 out of 10? 2, what the? What's wrong? 2 divided by 10? What's wrong? I could just, I guess I should just do 0.2. Maybe. That makes sense, I guess. Let's see. It's probably going to get closer than anything else we had, but that's still not a answer I really like. Yeah, that's horrible. 0.2. Delta. Let's see what delta is. Maybe that's a value that'll help us out a little bit. Okay, what the? So what if speed of orbit is equal to time for one orbit times delta? Let's see what happens when we do that. Yeah, let's see what happens. Let's see. So let's run it. Let's see. Might have worked. That's taken way too long. Never mind. It might have not worked. Dang. Was that 10 minutes or 10 seconds? Times. Okay, maybe. No, but then the higher this number is, that means the lower the speed. That's good, yeah. That's a good thing. Delta, I'm going to say delta divided by 10. I'll try that. Let's see what happens when we do that. That should give us a better result. Maybe something a little faster. Hello, hello, hello. Please. Please and thank you. What is going on? Where is this sun? Let's jump around a little bit. His jump force needs to be way higher, not gonna lie. Yeah. Maybe time divided by 100. Maybe that's the way. So we're gonna run it again. See what happens. Hopefully it's a little faster. Let's see. 0.016? It should be still taking forever. Okay. Let's just do 1. Let's do that. So that's this. Time for one orbit is 1 second. So it should be 1 second. That's already too long. We're going to divide it by 1,000. So if delta is 0.006 or something, then it should be now just 1 second. Or 0.1 or whatever. Why is it so slow? I don't understand. Why? That's weird. That's weird. Maybe another 10,000 is going to be... Okay, maybe it's not even moving at all, I feel like. That's what I feel like, honestly. Yeah. I'm going to print this speed of orbit and see what's actually going on here. Let's see. Okay, yeah, it's just making it worse. Yeah, we're making it longer. It should be times. Delta times. But that doesn't make any sense to me, because isn't time... If you multiply by a decimal, should be smaller, should it not? Or maybe I'm just stupid, maybe. Maybe I'm just stupid. Let's see if that's going to work. Let's see. Let's run it. Time for 1 revolution is 2 seconds. Even though we have time for 1 orbit is 1 second. So maybe take away a 0. Maybe that'll do something. Let's see. Nope, that's way slower. Way slower. Wow, wow, wow. Okay. Still didn't finish its orbit. Wow. 21 seconds when I did that. So what is delta? I don't get it. Print delta. Is it a big number or a small number? 0.016. So if that's delta, then multiplying it by this much, I don't know, I feel like that would not help, but let's just run it like that. Let's see what happens. It's taking even longer. Amazing. Amazing. Amazing, amazing, amazing. I'm gonna divide it. Who cares? Why not? Right? It's already gonna, there's no point, right? Yeah, it's still slow. Okay, never mind. Let me do times 1 over. Let's put this here. Let's invert it. Maybe that's gonna do something. Using our math brains, we're gonna use the inverse of it. Maybe that's gonna make it faster. No, it's not. Speed of orbit. Oh, we're gonna have to print this. Print speed of orbit. Now we're gonna run it. Let's see. Oh, that speed is 0.6. So that's not right. So 1 times 1 second should be times maybe I should do that. Maybe that'll make more sense. Oh shoot. Wait, what the, okay, it's going way too fast. Okay. Way too fast. So that makes the speed 6,000. We don't want it that much. Let's just do that. And let's see what happens there. Let's we don't need this print statement anymore. Let's run it. Let's see what happens. Speed for 1 revolution is 0.6, even though I want it at 1. What if I do it by 16? What if I do it by delta divided by delta times 100? This is stupid. This is some stupid math, I'll be honest. But I feel like it's gonna work. I don't know why. I have a feeling it's gonna work. What did I do? What did I do now? Expected closing. Oh, I didn't have it? Oh, I thought I did. Okay, that didn't work. But I feel like it's getting closer. I'm not gonna lie. I feel like it is getting closer. Delta. Because what if I did delta divided by 1.6? What would happen then? Let's see. Okay. What if I did it by times 2? If I did that. I'm just playing with the numbers now, honestly, because I don't know what else to do. Okay, that's obviously not it. So we're gonna do delta instead of multiplied by. We're gonna do divided by 2. This is too much stupid math. It's too much stupid, useless, stupid math. Honestly, it's dumb. It's dumb. It is dumb. It shouldn't work. Honestly, it shouldn't work. I was right. It's not gonna work. Divided by 2. Because that's going to be 0.0 something divided by 2. That makes so stupid. Delta. I don't know what to do for this math. I'm just an idiot. That's the problem, though. Let me, you know what? when push comes to shove, we gotta do what we gotta do. Write me a function that makes wait. Okay, so what I'm gonna do is copy and paste this part. Let me remove this, copy and paste this part of the whole thing. And I'm going to go to ChatGPT. How can I figure orbit based for one orbit? Let's see. Okay, so 3/6 speed of orbit is going to be 360 divided by time for one orbit. Delta speed of orbit is calculated by 360 divided by time for one orbit, which gives the degrees per second. That I feel like that's not gonna work, but let's try it. Okay, let's see. Okay, let's run it. Let's see what happens. I put it on 10. Why did I do that? Did I put it on 10 or no? Yeah, I put it on 10. That's not gonna work, obviously. That's way less than. That worked. Am I dumb? Why didn't I think of that? Why didn't I think of that? Orbit. This is in seconds. Alright, so now we have our orbiting body. And that's great. We've got the orbits done. Now, all we really need to do... of course, we need to... Okay, let me just hide this thing really quick. How do I do that? Sun. Let me hide it really quick. Now that we have the orbits and stuff for the planet, we have to, like... No, for the, sun body thing. We're gonna have to determine the sizes and stuff, the distance, and everything like that. But that's a very good news. Not only that, we can orbit like that, we can orbit any other object we want as well. So that's really good. You know, that's really good. That's splendid, honestly. So we've got that done. And also we have to create like a little character. We're gonna do that. We're gonna make some more planets, and then we're gonna get this thing hosted. Hope you enjoy.